Okay, starting video 3 with problem 17. If you look at the question, you'll notice nowhere in this problem does the word integral or the symbol for integral show up. This isn't necessarily an integral question. I'm asking you for the total area. So there are things that we can do to make this easier, but I think that they're jumping the gun a little bit. So this is going to be a little bit awkward, but we're going to get the answer. So the question says find the total area. And so if you're thinking about integrating, let's just think about what that would look like. If I integrate, say, from 0 to 2 of x squared minus 1, if I look at that, x squared minus 1 looks like this. So if I were to integrate, I would get this number right here, which would be some negative number. And I'd get this value out here, because that's under the curve. That's going to be some positive number. When I combine them together, I'm certainly not going to get the total area. I'm going to get some number that's, getting closer to 0. But clearly I have area. If I was painting this, there's something there to paint. So the integral, at least as an entire region, is not very well suited for this. So let's think about how we might be able to do this a little differently. If I did integrate this function from 0 to 1, that would get me this region right here, which is part of what I need. Except the answer I get would be negative. So I would get a negative number here. But if I just turn that number positive, then that would be what this area is. So I think the first thing we need to do is, in fact, integrate this. So the antiderivative is going to be 1/3 x cubed minus x. 3 comes down, I get x squared. Yep, that's right. From 0 to 1 gives me 1/3. So plug in 1, I get 1/3 times 1 minus, plug in 1. So I get 1/3 minus 1 minus, plug in 0 and I get 0. So the answer to this becomes 1/3 minus 3/3, which is going to be negative 2/3. So the integral says the area is negative 2/3, but we know that the only reason it's saying negative is because of the rectangles that we're using have negative values. So what we're going to do is just take the absolute value of that, and so we know that that little chunk right there is 2/3. So let's call this like maybe area A or something. So A is 2/3. Okay, so now if we integrate from 1 to 2, that would give me this area out here. And I don't want that area. But if you'll notice, taking that area I don't want and combining it with the area I do want gives me a rectangle. And so that gives me an idea that we could find the area of this rectangle. It's height of 3 and a width of 2. So I know that area is 6. And then if I find the area now of the integral from 1 to 2 of x squared minus 1. So find this area, and then 6 minus that should get me this region right here, which is called B. And then I can add the A plus the B, and I'll be done. So now I'm going to find the antiderivative, which I've already done. So it's 1/3 x cubed minus x, evaluated from 1 to 2. So when I plug in 2, I get 2 cubed is 8, so I get 8/3 minus 2 minus whatever I get when I plug in 1. Well, if you pay attention to what you've done, we've already plugged in 1 once. We plugged in 1 and got 1/3 minus 1, which we know is negative 2/3. So we can look for little opportunities to save ourselves some work, but in case you're not following that, let's just do it again. Plug in 1, I get 1 cubed. So 1/3 times 1 is 1/3 minus 1. So we get 8/3 minus, 6/3 minus 1/3 minus 3/3 is negative 2/3. So that negative and the negative I get here makes plus 2/3. So 8 plus 2 is 10, minus 6 is 4. The answer to the integral, that's all this is the integral, is, I lost my place, I think 4/3. So this piece is 4/3. So now I just need to do 6 minus 4/3. Or 18/3 minus 4/3. Which gives me 14/3. So that's the area of B. So I have B plus I have A. So the answer is going to be 14/3. Sorry, I'm getting a little messy here. I didn't give myself enough room. Plus 2/3. So the answer would be 16/3. And that would be the area of all of this, including that little part down there. Okay, so then we get to problem number 18, and it's a very similar question. If I look at this in pieces, I can see that if I were to integrate from 0 to 1 of the function that created this, so 3 minus 3x squared, then I can see that that should give me the answer to this piece right here, because the integral finds you the area from the curve to the function. So that would be this region. So I don't think I'm going to do this. I'm going to leave this for you to do. But when we do that, we're going to get an answer. Let's call it A. And it'll be a positive answer, so we should be in good shape. So we'll just set that off to the side. Then if I integrate from 1 to 2 of the function, that would find me this region out here, which I don't want. Let's call it B. So I don't want B, but that's what that would find me. So then I can use that. Again, I've made a rectangle here, and I can use that to find the part I do want. Let's call it C. So to get C, I would just have to find the area of the rectangle, which is 9 times 2. So that's 18 minus B. And so then the answer is simply going to be whatever I found up here for the A plus whatever I found for the C. And then that'll give me my answer. You can check the answer key for the exact answer. Okay, so the number 19 is asking us to find the area of the function, the area of the shaded region, which would be right here. One more final thought on this last problem. Keep in mind we want the area here as like a positive number, but when I integrate, it's actually going to give me a negative number, or better, because it's below the function. So I need to know, to take the absolute value of that, and then let's call that B. Okay, back to 19. So I want to find the total area. This one's going to be a lot easier than the last one. Pretty clearly, I've got two distinct parts. This top part is positive, and so the integral is a perfect tool to find the area there. So it looks like we want to integrate from 0 to 3 under the function. And that's going to give me a nice little positive number. Plus, I need to find the area of this, which again seems like I should go from 3 to 4 under the function. But when I do that, the answer to this is going to be a negative number. And I don't want it to be a negative number. So the quick, easy notation we could use to tell us to take something that was negative and make it positive would be to just put an absolute value around the whole thing, which isn't going to change anything. That's just our way of saying find the answer to the integral, which will be negative, and then make it positive. And so now it's just a matter of evaluating these two integrals. So let's at least do part of this. the antiderivative of 3x is going to be x squared. The x part is going to be x squared. Take the derivative, I get 2x. This is 3x. So the easiest way to do this, leave the 3 where it is, and then put the half down. So the 2 comes down, cancels out the 2, and we're left with 3x. Minus the antiderivative of x squared is going to be 1/3 x cubed. We're going to evaluate that from 0 to 3. Plus, then we're going to do the exact same thing. It's going to be the exact same antiderivative. So that's going to be 3/2 x squared minus 1/3 x cubed. Evaluated from 3 to 4. But I'm going to turn all of this positive when I get the answer. So now we just have some basic algebra. Plug in 3. 0 is not going to do anything, so we get an answer to that, which would represent the answer to the top. And then we got to evaluate this, which will give us a negative number, and we're going to take the absolute value. And I'm tired of this color, so let's do, let's do orange. Okay, so this problem, again, it wants to find the area right here. So it's going to be just like the last one. We're going to integrate from 0 to 2, it looks like, of the function. And when I do that, I can hopefully see that it's going to be a negative answer, and I'm going to want it to be positive. So I'll put the notation, let's make this thing positive. Now just do the math as we have been, and then evaluate and change the answer. Excuse me. And then we also need to find the integral from 2 to 3 under the function. This time we're expecting a positive answer, so I don't need to change the sign of this one. I don't need the absolute value, and I just need to add the two results together. Alright, we're at 12 minutes on this video, so I think I'm going to stop here. We should all be able to find these antiderivatives and plug in the numbers. Just take your time and then check the answer key to see the correct answer.